So today I'm gonna review a little bit about differential equations, and then I'm gonna try to solve the problem 3 in the midterm, because the problem 3 in the midterm will lead to the next chapter. All right? So let us start by reviewing a little bit about differential equation. Right, so the first thing that we know about differential equation is the first order differential equation, right? So first order differential equation will be something like u prime is equal to u, right? So this is one example in which you have a first order differential equation. So this is called a first order differential equation because here you have only one derivative, right? So you have a first derivative. So I want to review this because in the previous, in one of the office hours, one of the students asked me what is the meaning of boundary condition. And this is the meaning of boundary condition. So let us look into this equation. You have u prime is equal to u. So one solution for this one is the following. So you can see that one solution is u is equal to exponential of x. All right? So this is one solution to u prime is equal to u. Why? Because when you take the derivative of u, you're going to have exponential of x prime, and this is exponential of x, and this is u. Right? So this is one solution to this first order differential equation. All right? So I explain again. So here I have a first order differential equation. I have u prime is equal to u. Right? So I said that u is equal to e to the x is one solution to this one, because when I take the derivative of u, I get e to the x, and this is u. Right? So this is one solution to the differential equation. All right? So now, but you also have another solution. ux is 2 exponential of x. Right? So 2 exponential of x is also a solution. Why? Because when you take the derivative of ux, you're going to have 2 exponential of x prime, and this gives you 2 exponential of x, and this is 2ux. Sorry, this is ux. All right? So why do I say this? I'm trying to explain this to explain the concept of boundary condition. All right? So I explain again. So for differential equation, the first of the differential equations are equation in which you have the first derivative of a solution. So you have u prime is equal to u. You try to find a function u that satisfies this identity. All right? So one solution is u is equal to exponential of x. So this is a solution because when you take the derivative of u, you get e to the x, and this is exactly u. All right? Another solution is 2 exponential of x. This is a solution because when you take the derivative, you get 2 exponential of x prime, and this gives you ux. All right? So in general, you have solution of the type. We have solution of the type ux is equal to c times exponential of x. So c can be 1, 2, 3, square root 3, right? So in general, for this equation, you have a lot of solutions. All right? So it can be exponential of x, it can be 2 exponential of x, it can be c times exponential of x, and c is a constant that is chosen arbitrary. All right? So now I have the concept of boundary condition, right? Boundary condition. So in this case, we have many solutions. All right? So the boundary condition, so suppose that I want u0 is equal to 1. All right? So when I have u0 is equal to 1, there is only one solution that satisfies this condition. All right? So there is one solution. Is one solution, which is ux is equal to e to the x. In this case, c is equal to 1. All right? So in other words, the boundary condition is given so that you have one solution to the equation, right? So this is the concept of boundary condition. So I explained this because in my office hours, some student asked me, what is the meaning of boundary condition? So the meaning of boundary condition, as you can see from this example, is to identify one unique solution to this equation. Otherwise you can have exponential of x, you can have 2 exponential of x, you can have 3 exponential of x, and all of them a solution to this equation. All right? So if you put a constraint u0 is equal to 1, you have only one solution that satisfies this constraint, and this is ux is equal to e to the x. And basically this is the meaning of the boundary condition. All right? Questions? It's clear? Right, so you can replace this boundary condition by other boundary condition. Like u prime at 0 is equal to 1. So this is the Neumann. U prime of 0 plus 2u0 is equal to 0. So this is Robin. Right? So you can have other types of differential boundary condition because you can play the game with 0 or even 1, right? So this is at 0. And at 10, for instance, so you have u prime of 10 is equal to 0. U prime of 10 plus 2u10 is equal to 5. Something like that, all right? So you can play with those conditions, those constraints, and then you have other type of boundary condition. So if in the boundary condition you have a derivative, and so this is the Neumann boundary condition. If you have derivative plus u, then this is the Robin boundary condition. All right. So if you don't have derivative, then this is Dirichlet. All right. Questions? It's clear. So I explain again. So I want to review about differential equation, and I want to explain about the meaning of boundary condition. All right. So the simplest differential equation is the first order in which you have first derivative of the solution. So in this case, you have u prime is equal to u. This is one example. So in this example, you have several solutions, right? So e to the x is one solution because when you take the derivative of e to the x, you get e to the x. Or 2e to the x is also another solution because when you take the derivative of this one, you get exactly ux. Basically, you have plenty of solutions. So you can have one e to the x, or 2e to the x, or 3e to the x, or square root of 3e to the x. You can choose whatever constant here, and you get one solution. All right? So in order to have only one solution, you need a constraint. And this is called a boundary condition. All right? So suppose that u1, u at 0 is 1. Then there's only one solution that satisfies this constraint, which is ux is e to the x, that corresponds to the case when c is equal to 1. All right? But you can play the game with the constraint, right? So you can have u prime of 0 is 1 or u prime of 10 is 1. So they're both Neumann boundary condition because you have one derivative only. Or you have Robin, which is the mixing between one derivative and 0 derivative. All right? Now, so this is the simplest one. But we care more about the second order differential equation, right? Right, so second order. With constant coefficient. Coefficient. All right. So for second order differential equation with a constant coefficient, you have something like AU second plus BU prime plus CU is equal to 0. So this is homogeneous case, which means that the right hand side is 0. This is 0. Right? So the simplest second order differential equation is the one with constant coefficient. And here, this is 0, so I call it homogeneous. This is homogeneous because this is 0. All right? So this is the second order differential equation. So example, 2u prime plus u prime plus 3u is 0, or 3u second plus u prime plus minus u is 0, or even u second minus u is 0. So those are second order differential equation because you have the second derivative. All right? So I explain again. So this is a second order differential equation with constant coefficient because they are constant, right? This is 1 and this is 3. So this is second order differential equation with constant coefficient because the coefficient in front of all of the u, they're constant, right? So the general form of this is this one, AU second plus BU prime plus CU is 0. So this is homogeneous because u is the right hand side is 0. All right. So in the exam, this is non-homogeneous. But here, let us consider first the case where on the right hand side you have 0. Right. So this is a homogeneous case. So how do we solve a homogeneous second order differential equation? Characteristic equation, right? So this is the table. And yes, before going to the table, let us discuss about boundary condition. Right? So let us discuss about boundary condition. So you remember that I just mentioned the first order differential equation. So for the first order differential equation, you need only one boundary condition, right? So first order differential equation, order one boundary condition. Like u prime at 0 is 1. And u prime at 10 plus 5. U at 10. So let us focus with this. All right. So in the previous example, I say that the equation u prime is equal to u has one boundary condition. So in order to identify the unique solution, you need only one boundary condition, which is the condition at 0. All right? But for second order, you need two boundary conditions to identify the unique solution. All right? So second order, you need two boundary conditions, right? So you can have either u prime at 0 is 0 and u1 is 2, or u prime at 0 plus 2u0 is 5, and u prime at 1 is 2. Right? So those are two boundary conditions, right? Two boundary condition at 0 and 1. You can replace this by 10 and 5 or 3 and 4, right? But for second order, in order to have one solution, you need two boundary conditions. All right? Questions? Clear? Right. So I explain again. So this is basically the second order differential equation. AU second plus BU prime plus CU is 0. This is homogeneous because here you have 0. ABC are constant, like 2, 1, 3, or 3, 1, minus 1, 1, minus 1. All right? And so for first order differential equation, as I explained at the beginning of the lecture, you need only one boundary condition. But for second order, you need two. What I mean by two is that you have two conditions at 2 points, 0 and 1, or here you have 0 and 1, or you can have 5 and 10, or 3 and 4. Questions? Now, in order to solve this, we need the so-called characteristic equation. All right, so this is the table that you have to keep in mind. So this table was done in the differential equation course. Characteristic equation. So you have a x squared plus bx plus c is 0. Alright? So the characteristic equation associated to this one is like this. So you're going to have a is going to here, b is going to here, and c is here. Right? So for an equation like a u second plus b u prime plus c u is 0, I'm going to put a to x squared, b to x, and c to u. C to the independent constant. All right. Now you have to solve this characteristic equation, right? So solving the characteristic equation. So this table is something that you have to keep in mind because we're going to use that table a lot from now on. So I think it's worth that we mention it again. So in order to solve this characteristic equation, we have to consider the sign of this term, b squared minus 4ac. Right? So there are three cases. Case number 1, b squared minus 4ac is greater than 0. Right? So the characteristic equation has two roots. Alright? So the first one will be x1 will be, I'm going to say r1, will be minus b plus square root of b squared minus 4ac over 2a. And r2 will be minus b squared minus 4ac over 2a. Alright? It's clear? So if b squared minus 4ac is strictly positive, you're going to have two roots. The first one is minus b plus the square root b squared minus 4ac. The second one is minus b minus square root b squared minus 4ac over 2a. Questions, what happens if a is 0? What happens if a is 0?
First order.
It's first order, excellent. Yeah. Can you sign the magnitude, please? Alright, so if a is 0, this term is missing. So you're going to have a first order differential equation. So in order to keep this to be a second order differential equation, it has to be different from 0. Alright? Right, so in this case, you have two roots. R1 is this one and R2 is this one. So you have two solutions. Alright? The first one is u1 of x is x e to the r1x, and u2 of x will be e to the r2x. Alright? So then you're gonna find two solutions. u1 is e to r1 of x, u2 is e to r2 of x. What do I mean by two solutions? What I mean by two solutions is the following. When you replace these two equations, when I replace these two solutions to the equation, I have u1 second a plus b u1 prime plus c u1 is 0, and a u2 second x plus b u2 prime x plus c u2x, they're both 0. Alright? It's clear? So after I solve, in the case b squared is minus 4ac is strictly positive, I find two roots. The first one is minus b plus the square root of b squared minus 4ac over 2a. R2 will be minus b minus square root of b squared minus 4ac over 2a. So these are the two roots of this equation, of the characteristic equation. Alright? So that they are numbers. Right? So if I replace exponential of r1x and exponential of r2x, alright? Then I get two solutions for the equation. It's clear? So in general, ux will be c1 u1x, c2 u2x. So c1 and c2 can be any constant. All right. So in general, the solution will be u is c1 u1x plus c2 u2x. All right. C1 and C2 can be any constant. So so you're gonna have a u second plus b u prime plus cu. Right. So this is similar to the case where in the first order differential equation you have exponential of x, or 2 exponential of x, or 3 exponential of x. So to identify C1 and C2, you need the boundary condition, right? To find C1 and C2, we need the boundary condition. It's clear? So this is a table that you have to memorize. So I explain again. So in order to solve this a u second plus b u prime plus cu is 0, you're going to consider the characteristic equation, which is ax squared plus bx plus c is 0. This characteristic equation has two real solutions in the case where b squared minus 4ac is strictly positive. In this case, you have two explicit roots, which is this one and this one, all right? Then you're going to have two solutions, e to the r1x or e to the r2x. I can write it this way, so I can write exponential of r1x, and here I have exponential of r2x. It's the same notation, all right? Right, so those are the two solutions, meaning that you have a u1 second plus b u1 prime plus c u1 is 0, a u2 second plus b u2 prime plus c u2 is 0. All right, and the solution will be a linear combination of u1 and u2. You have to find c1 and c2, all right, by using a boundary condition. Questions? It's clear? So case number 2. Case number 2. I'm gonna erase it. B squared minus 4ac is 0. So how many roots we have in this case? One, right? Oh, one double root. So one double root. Which is R1 is b over 2a minus b over 2a. All right. So in this case, you only have one double root. All right. So which is R1 is minus b over 2a. So the first solution will be e to r1x, and the second solution will be e to r2x times x. All right. And then the general solution will be ux is equal to c1 u1 plus c2 u2x. All right. So this is the table that I gave you in one of the previous lectures, but I want to remind this knowledge here so that you. So this is case number 2. All right. So the second case, b squared minus 4ac is 0. So you have one double root, yes?
For the second solution, why is it R2 if there's only just one?
Thank you, yes, very good. Can you say at the back of the paper? So in this case, you have one double root, which is R1 is minus b over 2a. So u1x will be e to r1x, and u2 will be a little bit special. You have to multiply u1 with x, and u will be the linear combination of u1 and u2. All right? So case number 3. All right, so you're going to have b squared minus 4ac is negative. Right? So you're going to have two roots. So R1 will be minus b plus square root of b squared minus 4ac over 2a. All right? and this is b plus I square root of b squared minus 4ac over 2a. Right? So you're going to have the same solution, except that, okay, here you have minus b plus square root b squared minus 4ac over 2a, but this is a negative guy, so what you have is minus b plus I times square root b squared minus 4ac over 2a. Again, I remind you that I is something, when you take the square of that, you get minus 1. Right? Questions? And then you're going to have R2, which is minus b minus square root b squared minus 4ac over 2a. This is minus I minus square root of b squared minus 4ac over 2a. Alright? So it's gonna give you the same thing, except that you have to take into account the fact that b squared minus 4ac is negative. So it's the same solution. So you have b squared minus 4ac is negative, so this gives you minus b plus I times the square root of the absolute value of b squared minus 4ac. Alright? So I remind you that I is a special number in which when you take the square of that, you get minus 1. Questions? It's clear? So the two solutions will be u1 of x will be exponential of minus b over 2a x cosinus of square root of b squared minus 4ac over 2a of x, and u2 of x will be e2 2ax sinus of square root of b squared minus 4ac over 2a of x. Alright? So u will be the linear combination of u1 and u2. Alright, so this is the knowledge from 3133, I think, Introduction to Differential Equation. But I want to review it again. So I explain again. In case number 2, when you have b squared minus 4ac, you have only one double root, which is minus b over 2a. Right? So in this case, you have two solutions. The first one is the classical one. You have exponential of r1x, and the second one is x times the first one. And the general solution will be the linear combination of the two. Case number 2, this term is negative. When this term is negative, you have minus b, so you have also the same solution. You have minus b plus square root b squared minus 4ac, but this gives you an I because b squared minus 4ac is negative. Right? So this gives you an I, in which I is a number in which I squared is minus 1. And for the other one, we just change this plus into the minus. Alright? So then you're going to have, this is the general form of u1. So this part is coming from this guy. Alright? And this part is coming from this guy. Alright? So you're going to take the real part to be exponential and the imaginary part to be in the sinus and cosinus function. It's clear? So this is the table that you have to memorize from now on, because we're going to use that a lot. And this is the table that we have in the previous class, Introduction to Differential Equation. I think this is math 3133, right? Questions? It's clear? So now after reviewing everything like this, I'm going to go to problem number 3. Problem number 3. So we're going to use this table to solve problem number 3, and also the first example in the next chapter. All right. So problem 3. So problem 3 is the following: you have to solve minus u second minus 2b prime is equal to lambda u. So this is eigenvalue problem. Alright, so you have u0 is 0. And then you have u1 is 0. So b is a positive constant. So b is any positive constant that we have. Alright? So we're going to try to solve this one. So this is the solution. So problem 3 was solved on Canvas, but I want to go again over the proof so that you understand better how to solve this problem. All right, so the first step to do this is what?
Characteristic equation.
Yes, characteristic equation. Can you sign it back? So you have minus u second minus 2b prime minus lambda u is 0. So then you're going to have the characteristic equation. So you have minus x squared minus 2bx minus lambda lambda is 0. All right. So I can, because here I have minus everywhere, so I can change the size. So I have x squared plus 2bx plus lambda is 0. All right. So I explain again. So in order to solve this problem, the first thing that we have to do is to find the characteristic equation. You have minus u second minus 2b prime, bu prime minus lambda u is 0. So the characteristic equation for this equation is minus x squared minus 2bx minus lambda is 0. So because here I have minus everywhere, I can turn this into plus. Right? The next step is to consider what? Three cases, yes. Can you sign the second cases? So you have 2b squared minus 4, and so this is 4b squared minus 4, and this is 4b squared minus 1. This is lambda. This is 4 lambda. 4 lambda, and this is lambda. All right. It's clear. So I'm gonna consider b squared minus 4ac. So b squared in this case is 2b squared. 4ac will be 4 times 1 times lambda. So I have 2b squared minus 4 times lambda. So this is 2b squared minus 4 times lambda, and this is 4b squared minus lambda. Case number 1. All right. Case number 1. This is positive, right? B squared minus lambda is positive. It's clear? So we're going to follow this table. So this table said that, okay, you have to consider 2b squared minus 4 times a is 1. So minus 4 times 1 times lambda. So you have 2b squared minus 4 lambda. And this is 2b squared minus lambda. Right? So the first case is b squared minus lambda is positive. It's clear? So in this case, you have 2 roots. 2 roots. So you're going to have R1, which is minus 2b plus square root of 4b minus 4 lambda dividing by 2a. So this is 2. So you have minus b plus square root of b squared minus lambda. Oh, there's no b. Right? So, and then the second root will be minus 2b minus 4b squared minus lambda over 2. Minus b minus square root b squared minus lambda. Okay. So I'm going to use a table, right? So the table said that for this equation you have 2 different solutions. First one is minus b plus the square root of 4b squared minus lambda divided by 2. So you have minus b plus square root b squared minus lambda. The second one is minus 2b minus square root of b 4 times b squared minus lambda dividing by 2. So because I have 2 here, so I replace this by minus b minus square root b squared minus lambda. Right? Questions? So you're going to have 2 solutions, right? So the first one will be u1 of x is going to be exponential of e to the minus 4b b square minus lambda x. And the second solution will be minus b minus square root of b square minus lambda x. Right? So again, I'm gonna use a table. The table gives me exponential of minus b plus square root of b square minus lambda times x. And the second one gives me exponential of minus b minus square root of b square minus lambda x. Alright? So I don't explain why you get those solutions, but because this is from the previous class. But if you want me to explain it, I'm gonna take one lecture and derive this formula for you. Right? So I explain again. In the case when b square minus lambda is positive, you're gonna have two roots. The first one will be minus 2b plus the square root of 4b squared minus lambda divided by 2. So this 4 will go out as 2, so I can divide the 2 and I have minus b plus the square root b squared minus lambda. The second one gives me minus b minus square root b squared minus lambda. Alright? So you have two solutions. The first one is this one, the second one is this one. It's clear? Now, the general solution will be this one. So ux will be c1 exponential of minus b plus square root of b squared minus lambda x plus c2 u2x. So c2 exponential minus b minus square root of lambda x. Alright? So this is a general solution. This is c1 times u1. So this is u1. Alright? And this is u2 of x. So the general solution will be c1 times u1 plus c2 times u2. Alright? Now, c1 and c2 can be anything. It can be 1, 2, 3, 4, 5. Right? And all of them satisfy this equation, but we have the boundary condition. Right? So now you have to find c1 and c2 using the boundary condition. Alright? So now what you have to do is to find these two constants, c1 and c2, using the boundary condition. Right? It's clear questions? You understand the procedure? Right. So the boundary condition one is u0 is 0. Alright? So the first boundary condition is u0 is 0. So you have 0, u0 is u0, which is c1 exponential of r1x, which is 0, plus c2 exponential of r2 times 0. Alright? So I just have to replace 0 here. I replace 0 into u1 and 0 into u2. So I have 0 is c1 exponential of r1 0 plus c2 exponential of r2 0. Questions? So this is 1. So I have c1 times 1 plus c2 times 1. Alright? Which means that 0 is c1 plus c2. So in this case, I have c2 is minus c1. Alright? It's good? Questions? So, because c2 is minus c1, so ux will be c1 exponential of minus b plus b squared minus lambda x minus c1 exponential of minus b minus square root of b squared minus lambda x. Alright? It's good? Questions? Right, so now from the formula that we have before, you have a solution u can be expressed as c1 times u1 plus C2 times U2, right? C1 and C2 can be anything. Remember that before that you have U prime is U, so the solution will be exponential of C times E to the X, right? This is in the first, in the beginning of the talk. So in the beginning of the lecture, I have U prime is U, so Ux is C E to the U. So when I put U0 to be 1, then I can solve for C, right? So here we are trying to do the same kind of thing, right? So without a boundary condition, you cannot identify the constant, right? So this is what we have. So here is the same. So you have C1 times exponential of something plus C2 times exponential of something. So in order to find C1 and C2, what I do is I replace the boundary condition into the solution. So you have 0 is U0, which is C1 times 1 plus C2 times 1. So then 0 is C1 plus C2, which means that C2 is minus C1. So basically, I can replace C2 by minus C1, and so this is the general solution. Now I'm going to use the second boundary condition, right? So boundary condition number 2. I have U1 is 0. All right? So when U1 is 0, so I have 0 is C1 exponential of minus B plus B squared minus lambda, because here x is already 1, minus exponential of minus B squared minus lambda. All right? So I'm going to use the second boundary condition, which is here. All right? So the second boundary condition says that U1 is 0. So I'm going to replace 1 here. So I'm going to replace 1 here and here by 1. All right? So I put x to be 1 here. So I have 0 is C1 exponential of minus B plus B squared minus lambda minus exponential of minus B plus square root B squared minus lambda. So because this is different from 0, so which means that C1 is 0. You know that C2 is minus C1, right? So C2 is minus C1, so C2 is also 0. Right? So which means that the solution U is 0. And this is trivial. So basically this is a trivial solution, so we don't admit it as an eigenfunction or eigenvector. Right? Questions? It's clear? So I explain again, case number 1. So you look into this equation. You have minus U second minus 2b U prime minus lambda U0. So the characteristic equation will be minus, so this is minus, so this is minus, so you have minus x squared. This is minus 2b, so you have minus 2bx. This is minus lambda, so you have minus lambda. This is all minus, so I'm going to change everything into plus. In order to solve this equation, I consider 3 cases. The first case is b squared minus lambda is positive. So in this case, according to the table, you have 2 roots. The first one is this one, and the second one is this one. So the solution will be exponential of the 2 roots of x. All right? So this is going to be x here. So they are numbers, right? The 2 roots are numbers, but U1 and U2 are function of x because you multiply the 2 roots with x and you take the exponential. Now, the solution will be the linear combination of U1 and U2. So you have C1 U1 plus C2 U2. Right? So C1 and C2 can be any constant. Like in the previous example, when I have U prime is U, so Ux can be C e to the x, C can be anything. So by using the boundary condition, I can identify the C is 1. Right? So here is the same. I'm going to use the boundary condition to find C1 and C2. The first boundary condition that I have is U0, 0, which is a Dirichlet boundary condition, right? This is Dirichlet. And this is also Dirichlet. Right, so the first one is the Dirichlet boundary condition. I have to replace x to be 0, and u has to be 0. So I have u0 is u0, which is c1 exponential of r1 0, plus c2 exponential of r2 0. So this gives me 1, and this gives me 1, which means that c1 plus c2 is 0. So I find c2 is minus c1. I'm going to replace C2 into the formula for x. I have my C1 U1 minus C1 U2. Now I'm going to use a second boundary condition. I have U1 is 0. So I replace 1 into here and here, right? I have 0 is C1 this term, which means that C1 is 0. So finally I find C1 and C2 are both 0. So you have a trivial solution. Questions? So normally for the trivial solution we don't admit them and as the eigen function, alright? So case number 2. So case number 2, you have what? You have b squared minus lambda is 0. In this case, you have what? How many roots do you have?
One repeated.
One double root, yes. Can you sign it back? So R1 will be minus 2b over 2 times 1. So this is minus b. Right? Right? So basically, this is the first double root, right? So repeated root. So you have minus 2b over 2 times a. 1 is the constant in front of x squared, right? So you have minus b. So in this case, you have u1 of x will be e to the r1x. So this gives you e to the minus bx. And u2 of x will be x times e to the r1x. So this is x e to the power minus bx. Right? So in this case, you use a table. You find that there is one repeated root, which is minus b. Right? So the two solutions will be e to r1x. So this is e to minus bx. And the second one will be x times u1. Right? So this is u1. So the second one will be x times u1. So you have x e to power minus bx. Alright? Now, the general solution will be c1 u1 of x plus c2 u2 of x. So you're going to have c1 exponential of minus bx plus c2 x e to power minus bx. Alright? Questions? So what is the next step? Boundary condition. Can you sign the back of the paper, please? So you have boundary condition. So you have u0, 0. So which means that 0 is equal to c1 exponential of minus b times 0 plus c2 times 0 times exponential minus b times 0. Alright? So the first boundary so now you have to use the boundary condition. So here you have to find c1 and c2 using the boundary condition. Right? So now you have to find c1 and c2 using the boundary condition. Alright? So the first boundary condition is u0 is 0. So you have 0 is c1 exponential of minus b times 0 plus c2 0 times e to power minus b times 0. Alright? So this is 0 and this is 1. So you have c1 times 1 c1. Right? So basically c1 is 0. Alright? It's clear? So I explain again. So the first boundary condition gives me something very simple. You have c1 is to power minus b times 0, which is 1. So you have x times e to power minus x, so this is 0. So basically c1 is 0. Boundary condition, this is boundary condition 1. This is boundary condition 2. You have u1 is 0. So, so from here you can find that ux is only c2 e x e to power minus bx. Alright. So from the second boundary condition, you find that 0 is C2 times 1 times e to the power minus b times 1. So C2 will be 0. So basically Ux will be 0. So this is trivial solution. Alright? So for the second case, you also have a trivial solution. So in the next class, I'm going to try to go over case 3, and I'm going to go to the first example of the next chapter.